Greetings, folks. Welcome. When economists do regression analysis, we're often interested in testing a hypothesis about how we think the world works. To do this, we'll often start from a regression model, and here you see a generic form of a regression model, where it's y, that's the dependent variable, that's what we're trying to explain, equals beta subscript 0, plus beta subscript 1x, where x is an explanatory variable or an independent variable. That's the factor that we think might have an impact on y, the dependent variable, plus epsilon, which stands for the error term. We use an error term to recognize that there are lots and lots of other factors other than x that might have an influence on the dependent variable. Unfortunately, we really never have access to an entire population, so instead we conduct our regression analysis using information from a sample. So here's a sample regression model, y equals b subscript 0 hat plus b subscript 1 hat times x. The specific application I have in mind is the effect that studying has on a student's grade. So grade's the dependent variable. That's what we're trying to explain. Of course, everybody wants to know what's the key to a good grade. And that's equal to beta subscript 0 plus beta subscript 1 times the amount of time you study plus epsilon, where epsilon accounts for anything other than time spent studying on your grade. And the sample regression model is written as grade equals b subscript 0 hat plus b subscript 1 hat times time spent studying. The first step of doing a hypothesis test is writing out the null and alternative hypotheses. Of course, my claim is I think that studying has an impact on a student's test score. So we take the claim and we write that out as the alternative hypothesis, h subscript a, beta 1 is not equal to 0. And the null hypothesis is that the alternative, or that the claim, is not correct. So the null hypothesis is written out as h subscript 0, beta 1 is equal to 0. If beta 1 is equal to 0, that means that the time spent studying has no effect on your grade. Of course, my claim is that it does have an effect, so therefore beta subscript 1 is not equal to 0. The second step of conducting a hypothesis test is setting the significance level. And I'm going to use alpha equals 5% or alpha equals 0.05. This is a probability of making a type 1 error, which means that we reject the null when in fact the null hypothesis is true. In the context of this example, if we made a type 1 error, we would reject the idea that beta 1 is not equal to 0. In other words, that studying has no effect, in favor of our claim that it does have an effect. So we would mistakenly conclude that studying does have an effect on a student's test grade. The third part of a hypothesis test is the fun part. That's collecting the data and doing the research. So here you see information on a sample of 40 students. You see their test grade on the y-axis. You see the amount of time spent studying on the x-axis. Here we have our regression result for b subscript 1 hat, and that's 2.732 with a standard error of 0.337. I got these values using statistical software using a computer. So this means that as you increase the time spent studying by 1 hour, it improves your test grade by 2.73 percentage points. So we can use our regression results to calculate a test statistic, which in this case is a t-statistic. Here's the formula for calculating the test statistic. T equals b1 hat, this is the value from the research, minus beta 1 naught, this is the value for beta 1 from the null hypothesis. We divide this by the standard error of the sampling distribution of b subscript 1 hat. So you might think the formula for this test statistic looks familiar, and you're absolutely right. If you're conducting a hypothesis test about a mean value, the test statistic is t equals the value from your research, which is x bar, minus mu sub naught, which is the value from the null hypothesis, divided by the standard error of the sampling distribution. So it has an identical format, it's just the notation is different. Likewise, if you were conducting a hypothesis test about a proportion, the test statistic would be z equals p bar. This is the value from your research, or the proportion you get from your research, minus p subscript naught, which is the value from the null hypothesis. And then you also divide that by the standard error of the sampling distribution. So once again, a very similar format. So now let's go back to the formula we used to calculate the test statistic from the regression analysis. So again, you have t equals the value from your research minus the value from the null hypothesis divided by the standard error. So the t-statistic tells you how many standard errors the value from your research is away from the value in the null hypothesis. So if you have a large value, it means that your research is really far away from the null hypothesis. If you have a small value, it means that the value from your research is pretty close to what you would have in the null hypothesis. So now we can wrap up the value of the test statistic. It's t equals 2.732. That's the value for b subscript 1 hat from your research. You subtract from that 0, which is the value from the null hypothesis. The standard error is 0.337, so we have a t-statistic of 8.11, which tells us the value from our research is over 8 standard errors away from the value in the null hypothesis, which we had as 0.